Okay, so this is the example 4 from your book. Let's start by drawing the free body diagram. Okay, we are supposed to find the tension in the cable and the force in the boom. So if we have this force, we have a tension acting in this direction. Okay, we have a weight pulling down, and we have a boom with a force in it going that way. Alright, and so we're going to do this. B, this is a weight that's 100 pounds. That's just suspended off that string. Okay, so now if we look at this and we say, okay, well, let's draw in our X and Y. Alright, we know that this one is at 30 degrees. Okay, and this one is going to be at 50 degrees because this angle was 40, the overall angle here is 90, so this one has to be 50 degrees. Alright, and that 100 is acting straight up and down. We're at equilibrium, so let's start by writing the sum of the forces X is equal to 0 and the sum of the forces Y. Okay, which forces have X components? The 100 is straight up and down, so only it's T and B. Alright, and so it would be Tx and Bx. Alright, now T is acting in a negative X direction. And B is also acting in a negative X direction, so we'll say that is negative as well. Alright, so now we'll start plugging in for what things are. 0 is equal to T. Okay, the X component of that is going to be cosine 30. But it was negative, remember. Minus, okay, this one also has an X component, so that should be B cosine 40. I'm sorry, cosine 50. Alright, we have one equation and two unknowns. We really need to go, we can go ahead and solve this for one of them. And so let's move the T to the other side. Alright, so T cosine 30 is equal to negative B cosine 50. Alright, now I need to divide both sides by cosine 30, and I get T is equal to negative B cosine 50 divided by cosine 30. Alright, now let's write the sum of the forces Y. It's also equal to 0, and that's going to be equal to Ty is a positive number minus Tx, minus By, okay, minus 100, because those are both acting in negative Y directions. Alright, so let's plug in for those. That would be T sine 30 minus B sine 50 minus 100. Alright, now I can take this T I solved for and plug in here. Then I'll only have one equation, one unknown left. So 0 is equal to negative B cosine 50 divided by cosine 30 minus B sine 50 minus 100. I'm going to pause for just 1 second while I do some plugging on my calculator. Okay, so when I plug that into my calculator, I get negative 1.508. Oh, okay, negative 1.508 B minus 100. Okay. So then I'm going to, if I have a negative number on both sides, I need to move one to the other side. Alright, so I'll move the B to the other side. 1.508B is equal to negative 100. I divide both sides by 1.508 to get negative 66. .3 pounds. Okay, so what does this tell me that I got a negative B? It tells me that I drew this force backwards. Okay, I don't need to correct that now. Alright, all I just need to make a note is that B was drawn that way. We will continue, if we have more calculations to do, that B was drawn that way and keep it in the same sense and keep using its X and Y's like we've drawn it, because that's how we've set up our equations. Alright, now we plug that back in up here and get T equals negative 66.3 times cosine 50 divided by cosine 30. So T is equal to 49.2. pounds. Okay guys, so I don't know if you caught it, but I left a piece out here. When I substituted for T here, I needed to also multiply by sine 30. Alright, so that's also then times sine 30. Makes a big difference. Okay, so then let's go back and figure out what that works out to be. It is cosine 50 divided by cosine 30 times sine 30. Okay, so that's 3.711 plus R, and that's a negative, and we also have a negative sine 50. Alright, and I get 1.137 B. Oops. B. Alright, so then I this 137 because it's moved to the other side. Alright, so B's still negative, but it's 100 divided by, and I get 87.9. Okay, so still drawn backwards. Alright, now I plug this in, negative 87.9. Alright, and I end up with T equal to 65.2. Alright, so I hope that helps. Catch you next time.